right, we're going to continue today talking about quadratics, and we want to talk today about a couple of things. We want to talk about domain of quadratic functions, and we want to talk about the range of quadratic functions. So let's take this opportunity while we're talking about those two things to do a quick review of what happens when we try to graph a quadratic that's in vertex form. So I've got x minus 4 squared minus 2 as my quadratic function that is in vertex form, and we're going to graph it very quickly on the coordinate plane. So let's just sketch us out a very quick little graph on our coordinate plane and mark off a few units here. These are in single units, and so we'll mark a couple of those so that we know that, and talk about what this is going to look like. First of all, notice that there is no value given here for a. So think about that. What would your value of a be if there is no given value of a? And I think that if you think about it, you'll remember that that must mean that there is a 1 sitting in front of that function, even though we don't usually write that. So our a value is greater than 0, and so we have a smiley face function. It is positive, it's going to open up, it's going to have that general shape to it. And since a is equal to 1, we're not going to modify anything from the normal shape of our graph. Now what's the vertex? The vertex, remember, is hk, so in this case it's 4, -2. That's the vertex of my function. So let's graph that point right here. 4, -2 is the vertex of my function, and we have an axis of symmetry at x equals 4. So it's going right through our vertex. So there's our axis of symmetry at x equals 4. So let's put a few more points on, and by now you should be getting pretty confident with the fact that as long as this a value is 1, we are going up 1 and over 1 to get to this next point. 1 squared is 1. We're going over 2 and up 4 because 2 squared is 4, and over 3 and up 9 because 3 squared is 9, which gives us a coordinate here of 4, 5, -1, and 6, 2. Notice that we're not at 4 now, we are at 6, 2. We are up 4 from our vertex, and because we are talking about a quadratic and it's symmetrical, it's got to be the same on this side as it is on this side. We have a point here, we have a point here, and we have a point here. So let's draw in our parabola, and this is the graph of our quadratic. So now that we have that, let's talk about what we want to talk about today, which is the domain of the function and the range of the function. Remember that domain is going to be which values on your graph. If you think about that, we've talked about it before, the domain of your function is the x values. It is the values of the function for which the function is defined. Well, if I continue this function on out forever in both directions, is there any x value that our function is not defined at? We know it's defined here at 4, it's defined at 3, it's defined at 2, it's defined at 1, it's defined at 0 if we continue. It's defined, if we make this big enough, can you see that it would be defined at 10 or at -10? So our domain of this function is all real numbers, because our quadratic is always going to be valid or defined at any x value that I want to put in. And we can write that like that with our funny looking little r if we want to say that it's all real numbers. But the range of our function is not all real numbers. Notice I can get a y value of 0. In fact, I can get 2 of them. I can get a y value of 2. I can get a y value of -2. But does this thing ever change direction? No, we know that our parabola is the shape of our function, and so this never turns around and comes back down. So the lowest possible point I can get is this vertex of my function, which is at 4, -2. So I have a minimum value of -2. Well, that tells me what my range is. My range is y is greater than or equal to -2. It starts at -2, it is defined at -2, and it goes up from there. It never turns around and goes back down. And remember, we can write that in interval notation as bracket -2. It's a bracket because it includes the -2, comma, infinity. It goes forever, and that's a positive infinity, and we always put parentheses for an infinity because can you ever actually get there? No, you can never actually get to infinity. So we define our range of that function as -2 to infinity, or y is greater than or equal to -2. All right, well, let's try one that opens the other way. And again, let's use this as an opportunity for review. We'll do f of x is equal to -3 parentheses x plus 1 squared plus 2. So again, we're looking at the vertex form of a function. So we know that our a is less than 0, which means we've got a frowny face parabola. We know that the absolute value of a, this absolute value of -3, is equal to 3. So we're going to have a vertical stretch on this graph. And our vertex comes from this 1 and this 2. So our vertex here is at -1, 2. Remember, this is x minus h, so it would be x minus a -1. So I have a vertex at, and I wrote that wrong, -1, 2. All right, so -1, 2 is the value of my vertex. So let's graph this, and we'll sketch out very quickly our coordinate plane. And put our units on here, and we're marking this off 1 unit at a time. So this is 1, and this is 2, and the same thing going up. This is my x-axis. So my vertex here is at the point -1, 2. And I have a vertical stretch by a factor of 3, and this thing opens down. Remember, I've got a negative there. So I'm going to go over 1 and down 3 on both sides of my axis of symmetry. So I've got points on either side of this axis. Let's sketch in my axis here. My axis is at x equals -1. And then I can graph my function. And that's just a really quick sketch. I would want you to put a few more points on that normally, but it gives us an idea of what this looks like. Well, what's the domain of the function? If I want the domain of that function, did I do anything to change the domain? No, I didn't. It's still going to be defined no matter what the x value is. So the domain of this function is also all real numbers. What about the range? We have something a little different this time. Our range, our y values, we're not going up from our vertex. We're coming down from our vertex. So these y values, y is less than or equal to, what is the y value of my vertex? The y value of my vertex is 2, so y is less than or equal to 2. And I can write this, remember we always put the lowest number first, so my least number here is -infinity because this goes down forever. And I use a parentheses for that. We always use a parentheses for our infinities because it never really gets there. Up to a value of 2. And it gets a bracket because it does reach that value of 2. Remember, we're talking here about a maximum value, and the maximum value here is 2. We're talking about the y value when we talk about minimums and maximums. Over here, we're talking about a minimum value because we have the bottom of this parabola and it goes up from there, and my minimum value here is -2.